My name is Ece Kamar. I'm a researcher at Microsoft Research, and my area of study is artificial intelligence. I'm an artificial intelligence researcher from training, but through time, I really got interested in the human aspects, both in terms of how we can build AI systems that can help people, but also more recently with the increase of crowdsourcing. I'm very interested in how the crowds can help AI system, and that's what I'm going to be talking about today. So we are going through an exciting time in the field of AI overall. When I was doing my PhD like a decade ago, and somebody would ask me, like, what are you working on? The advice I got from some people was, never talk about AI. Never say that you are doing AI, because everybody is going to think whatever you are doing is going to have no influence in the world, or they are going to think that you are doing some crazy thing. So now being here, you know, in 2017, reading all of these articles in newspapers about how AI is going to change everything, and how AI is going to take away jobs from human, or how AI is going to solve all of our problems, it's a quite interesting shift. And when I go back and think about where this shift is coming from, this is my personal perspective, many of this shift comes from the advances we have in some machine learning algorithms fed with a lot of data. And combination of this with deep learning algorithms doing great successes in perception tasks, or tasks that are very well defined, like the Go game that DeepMind did great on. One example of that is visual perception, how now we can train machine learning algorithms to recognize different objects in images. And in 2015, researchers have reached human level parity in object recognition. Recently, there has been a similar success from Microsoft Research in speech recognition, where on some well-known data sets, machine learning algorithms reached human-level parity in speech recognition. And now the good thing is, these advances are not staying in labs, they are making their way into real world. For example, because I'm from Microsoft, we have the Skype translator system where you may speak in real time. The system translates what you're saying in real time to a different language, so that the person you're talking to can just understand you without knowing your language. So now we are seeing a lot of these technologies making their way into real world products and services. And in all of these discussions around AI and how AI is progressing, we see a lot of emphasis on algorithms. For example, how deep learning is doing so much better and so forth. However, one thing I think is underrepresented, underemphasized in the discussion is the role of data, and actually the role of the crowd. So the algorithms we have working very well for these real world applications are so data heavy. They are actually more data heavy than other algorithms like logistic regression or decision trees, because they need a lot of data to learn the structure of the data and then do the prediction afterwards. And a lot of the advances we had in speech recognition, also in object recognition, they come from these data sets that are beautifully crafted and very much larger in size than what was possible 10 years ago. And we owe a lot of that success to paid crowdsourcing platforms like Mechanical Turk, to citizen science platforms like Zooniverse or other platforms, and also to the collective development platforms or content generation platforms like Wikipedia, Twitter, where, for example, a lot of Twitter data is used for training dialogue systems. And this paper is from 2001, but it is true today too if you repeat the experiments. Mainly what this is saying is, if you look at why an algorithm is successful, is it the machine learning algorithm that underlying, or is it the data? We see that the data is the #1 factor. Having high quality, large scale data for a lot of problems is the #1 factor of making these machine learning algorithms work. And then you are getting some benefits from choosing the right machine learning algorithm, but never underestimate the data. And this is even more true today with data-hungry deep learning algorithms. So in the last year or two, I started really thinking about what happens to these systems in the wild. So despite these advances I told you about and the human level parity we get in the lab when we are evaluating these algorithms, when we put these systems in the real world, in the hands of real users, we still see that these systems fail, and sometimes fail very miserably. One of the examples come from Google, Google built this object recognition software, put it online, gave it in the hands of the users, and the algorithm actually works surprisingly well for some instances. For example, on the top middle square, you can see from a very partial view of an airplane wing, this algorithm can recognize that there's an airplane there. However, the obvious problem happens when two African-American teenagers gave their picture to the system, and the system came back saying it's gorillas. Google is not alone. Our systems, Microsoft systems, has a lot of problems too. And one big scandal happened when, as an organization, we built this conversational bot called Tay, gave it in the hands of users on Twitter, and without human supervision, just letting the system run with whatever the algorithms they had inside, this algorithm started behaving very badly very soon. So initially it was very innocent, it was having conversation, it was trained on Twitter, but after a while, incorporating the feedback it was getting from the people that it was interacting with, it turned into a racist, all kinds of problematic agent. And I really like this quote from this Twitter user who says, Tay went from humans are super cool, that's what it was saying when it was first trained, to full Nazi under 24 hours, and I'm not at all concerned about the future of AI. So my personal research focuses on the combination of human and AI, and how we can have human intelligence in the loop to prevent some of these errors, to prevent some of these shortcomings of AI systems. Basically, I believe putting human intelligence into the loop, not only in training, but in execution, in evaluation, figuring out what our system is doing right, what they are doing wrong, is key to develop reliable, trustworthy, and responsible AI systems of the future. And this idea is not my idea only, and it is not something that just appeared. It's a technique that is being used in the field for a very long time, trying to form that partnership between the human and the machine and figure out how we can have humans complementing what the machine is doing. And that's exactly why you have some Tesla cars, semi-autonomous vehicles on the streets today. They would fail miserably if the human doesn't interrupt in every number of minutes. You know, some Tesla cars cannot even recognize the traffic lights on the streets. I think they are getting there, but that's one of the shortcomings they have. So how come they still drive around without having too many accidents? Because they are designed to be a hybrid intelligence system where they heavily depend on the human input, having the human in the loop, watching everything the car is doing, intervening whenever it's necessary, and kind of having that loop. And we can always discuss, I'm happy to discuss where this breaks down and what are other challenges that happens when you have this loop in real time, but let's put that to the side. And it creates this virtuous loop between the car and the human, in the sense that the human is always validating what the machine is doing and providing data to the system saying this is where you made a mistake and this is how I corrected you, which can later be used to improve these systems. Another power of the hybrid is that humans and machines have complementary abilities. So although a lot of the test cases and the challenge problems we set for AI systems are just replacing what the humans are doing, there is actually a lot of potential just figuring out what humans are good at and what machines are good at. So I borrowed this slide from a presentation from Murray Campbell, who was one of the people who developed the original Deep Blue system at IBM, who mainly solved the chess problem or reached human-level performance back in 1990s. And what he shows in this graph is that they track human-machine performance in playing chess through the years. X-axis is the year, Y-axis is the proficiency of these players in terms of playing chess. And not surprisingly, the blue line is the performance of the human, and that's not changing much because we've been playing chess for a very long time and we are getting a little bit better, but not significantly. The improvement for the machine, which is the red line, is of course very substantial because our algorithms are getting better, we are computationally more powerful these days. The interesting thing is the green line. So the green line is a human and a machine playing chess together. So they created a workflow such that the human can look at the suggested actions of a machine chess player and provide advice and kind of give feedback to each other to figure out what is the best action to take. And this hybrid version of gameplay is still doing better than the machine. So the one point I want to make is that a lot of the work, both in crowdsourcing and in machine learning, focuses on what happens in the lab. How we can collect better training data, how we can clean up our data, what is the label aggregation process looks like, and so forth. However, one message I want to give you today is that more important, or equally important or more important, is what happens when these systems are functioning in the wild with real users, and how we can get the human input, feedback, and supervision into the execution data. This is the data that is collected during execution, and figure out what these systems are really doing. I believe as we put these systems into more critical tasks and into the real world, these issues in terms of troubleshooting, figuring out where our systems are making mistakes, what are the shortcomings, what are the blind spots, how does these systems fail, and what are the best strategies to fix them, is going to be increasingly more important. And this is one area this group of people working on collective intelligence and the crowd, can have a big influence on. One particular type of error that I am very worried about is the biases in machine learning systems. So what we see is that in these systems, it is not like these errors happen randomly. They happen due to some biases we have in the training data. And the way these errors manifest themselves are particularly for some subpopulation of users. They are not happening just for everybody. So one example is the African-American teenager and the gorilla example I told about before. Another example is the face recognition softwares we have today. Unfortunately, when this MIT Media Lab student, Joy, tried to work on face recognition software for her research, she realized that these systems are not working for her, and the only way she can work with face recognition softwares of today is putting a white mask in front of her face. Clearly, this is unacceptable. Another example comes from this passport photograph example, where this Asian man tried to input her image into the system. He kept getting this error saying that your eyes are closed and your image is not acceptable for the system. Again, these errors are not happening randomly. It may not happen for me, although the speech recognition, the robot in my building that uses speech recognition never understands me because first, I'm not a native speaker and I'm a woman. So again, these errors are affecting us in many different ways as subpopulations. And a lot of these problems actually link to the diversity problems we have in computer science overall, but again, that's a different conversation. So I've been doing some work with my colleagues in terms of figuring out how we can use the crowd and the AI algorithms together to detect these type of errors, which we call blind spots. So basically, blind spots occur due to these special errors called unknown unknowns, where the machine is making these mistakes without even suspecting them. And when these errors concentrate around some feature spaces, they are the blind spots of machine learning algorithms. So that's a very quick definition of the kind of problem we are interested in. I'm not going to go into the details of how we are doing the detection. There is this great paper from Panosipouritis and his colleagues called Beat the Machine that first talked about these unknown problem. And recently, we've been thinking about how to use AI algorithms with humans to speed up this discovery process and actually have interpretable representation of these blind spots to be given to the system designer. Another area of work we do is in terms of troubleshooting more complex AI systems. So what we have in the field these days is not a single classifier working to solve a task, but a combination of classifiers and decision-making models, having complex interactions to solve complex problems. Image captioning, the example I have here, where the system writes a one-sentence description of what's going on in an image, is a simple application, but still has three components that are connecting and communicating with each other in complex ways. And the problem is when we have this kind of a non-modular entangled structure, understanding where errors are coming from and figuring out the best ways to fix them and improve them becomes increasingly more complex. And that's another area of work we do in terms of thinking how we can have humans in the loop in the troubleshooting process, simulating some of the fixes we are really thinking about, and enabling more informed decision making from system designers about making these systems better. So what I would like you to leave the room today from my talk is really have an idea about the complex problems we have ahead of us in the space of AI, and mainly how AI is going to be working and interacting with humans, which is even a more complex problem than solving the AI problem itself. So there are a lot of issues around responsibility, having reliable systems, transparency. With these algorithms we have, they are becoming increasingly hard to debug and understand what they are doing, which is a big issue. Biases, fairness, these are all coming up as important problems. And there are big implications to not only to computer science, but to policy and law in terms of what these systems are going to mean for daily life. And because these issues are becoming so important, we see experts in the field writing reports, contributing the reports in these subjects. Of course, we have the White House reports that came out last year on these subjects of artificial intelligence and also the future of work. But one study I was personally involved in is the Stanford study on artificial intelligence and the impact of artificial intelligence on daily life, where I worked with 17 other experts in the field, where we try to understand what are the big opportunities and challenges for AI in daily life, and what are the interactions with policy and law, and what are our recommendations for the next 15 years. So my message is, don't listen to what newspaper says, no AI is perfect. There are AI systems that are going to be making mistakes, and there are complex issues surrounding the mistakes that AI does. And these complex challenges require collective effort, so I would really like to see more effort in this space going to the future. Thank you very much.
So we'll take a couple of questions now for AJ. Raise your hand.
I see value in that because I think a lot of the recent challenges we've had in the field only focused on replacing the human or doing tasks that humans are good at. And as we do more progress on this problem, I think people are realizing that actually the harder problem is the interaction between human and the machine. And any challenge, any effort in terms of putting more emphasis on that problem and really highlighting what are the big issues we have and what are the research problems we should be studying in the field, I really appreciate that very much. Another thing I think that the human-machine collaboration subfield has lacked over the years is having a challenge problem. So a lot of researchers have talked about these problems over the years, but in a very abstract way, people came up with algorithms, but we lack the benchmarking that, for example, machine learning people have in terms of having the common data sets, having common challenge problem, and also track progress. So I'm really happy about bringing those properties into the researchers and promoting research that way. However, there's always the issue that whatever challenge problem you choose only highlights some of the issues, so you need to be open. It's not going to include all problems in the field, but it's going to be a start.
Thank you. There's a question at the back.
Hi, AJ. Saigar Rajla from University of Michigan. I was wondering what sort of role you see people playing in terms of combating like the spread of disinformation and stuff, the sort of false information that was very prevalent in recent political cycles, and whether you see companies sort of trying to combat that by including people in the loop?
That's a great question. So I think, in my mind, the solution of that problem is not going to come from machines, it's not going to come from humans, it's going to come from them working together. One problem with information is that the growth of the information that is surfaced to us every day grows exponentially. And that's something we see as academics in the field, that, how do you keep up with the papers that are coming up every year? And you have the same problem when you're following news. Basically, it is just there's so much information, it is very hard to make sense of it. And that's why I think having the machine and the human collaboration is very important, because machines can detect patterns. However, machines cannot really figure out, especially as things are changing so quickly, what is this cluster of things really look like? What is the meaning of them? What are the risks associated with them? So I think something that can make sense of the overall data structure and have humans' eyes on these and trying to make sense of the world is going to be a good solution. The thing is, though, a lot of those problems about information, especially changing what true means, is like a security problem. In the sense that there are intentional agents, humans, on the other side that is kind of reacting to all of the strategies you are taking today and changing the way they are doing it in a way that they can fool whatever algorithm or human-machine partnership you have in a way that you can fool things. So I think we also have a lot to learn from the security experts in terms of how they were not winning that race, but actually participating that race and reacting to all of the advances happening.